Hello, welcome to section 7.3. Today we're going to be identifying functions from tables. Now if we have a linear function, they're going to have an add pattern. So if you look here, if I add 2 each time, I should consistently add the same number. And on this side, I'm adding 3. So for every 3 I go up in y, I'm going to go 2 over an x. And hopefully everybody knows you can find the slope by just dividing those two numbers. So 3 over 2 is going to be our slope. So for this, we're going up by 1s. 1s all the way down. So what we're doing here is we're going down by 2s. So my slope is just going to be negative 2 over 1. Now for quadratics, they have something that's a little unusual. We call it the constant second differences. So if I find the differences in each of these values, say 303 minus 230, I'll get 73. 230 minus 167 will give us 63. 167 minus 114 will give us 53. Now I made a mistake. This was actually supposed to be 73. I just put 70 down. And then this will be 43. Now, these are not the same number. Like in linears, those are all the same number. However, if I go out one more step, the differences of the difference, or the second differences, those are constant. So the first differences are constant, but the second ones aren't. So let's look at this one. Here we're going up by 14, then by 20, then by 26, and you can see this is going up by 6, going up by 6, so this should be 32. Here's the pattern. Is 32 plus 66 98? Yes, that is correct. So our constant second difference will be 6. Now, exponentials follow an add-multiply situation, where here if I add 2, add 2, add 2, and so on, really what I'm doing over here is multiplying by some number. So 135 divided by 15 is 9. So I'm multiplying by 9. And over here, if I add by 2 again, I need to multiply by 9, multiply by 9, multiply by 9. So this is, we're adding in the x column and multiplying in the y column. Alright, on my table to the right, here I'm adding 1 each time, and here we're multiplying by 1/4, which is the same thing as division, but we can still say we're adding here and multiplying over here. Alright, for logarithmics, since a logarithmic function is the inverse of exponential, we have the opposite pattern. So this one is, oops, I didn't mean to do that. I guess it's stuck like that. Oh well, we can deal. It's a multiply add pattern. So I'm adding over here, and I'm multiplying over here. Was this the opposite of the previous one? Here where we're multiplying by 9? Same thing, but now we call it multiply add because we're multiplying our x's and adding our y's. This is an addition sign. So in this column over here, we're going to do the same thing. Here we're adding 1 on our y's, and our x's we're multiplying by 1/2. Hopefully you see that all the way down. Alright. Now our power functions, this is the most complicated one because it's a multiply. And it's hard to see when there's values that aren't just the values that are in the function. So, or in that pattern. So if I do 3 times 2, I get 6. 432 divided by 54 is 8. So this is a multiply by 2, multiply by 8 pattern. So if I multiply 6 by 2, I don't go to 9, I go to 12. So from 432 to 3,456, we should multiply by 8. Now we can't multiply this by 2 and still be in our function, but if I guess I could have it out here. 24, if I multiply that by 2, I got 24. That would be 3,456 times 8, which is 27,648. Now, that same pattern exists if I start here. If I just do 9 to 18, I multiply by 2. So those two should have the same pattern. So if I take 1,458 multiply by 8, I do get 11,664. So no matter where you're at in the graph, you can still multiply by 2, and you'll be multiplying the y values by 8. Over here, let's pick anything. Let's go from 2 to 4. So if I multiply by 2, what am I going to multiply over here? So 2,048 divided by 64 will give us 32. So if I multiply by 2 again, that would get us to 8, which isn't necessarily in our function. We could put it on there. But if I do 3 times 2, that should equal the same thing as 486 times 2. Wait. Nope, that's not true at all. 486 times 32, which is 15,552. So there's a multiply situation going on here. So power functions get quick very, very quickly. You can see because you're multiplying both the x and the y's. And exponentials get quick fairly quickly also. So if we take a look at this, what is this? Going up 2 and up 2. So that's linear because I'm adding on both sides. Here, I'm going up 2, and so 49152 divided by 786,432 is 1/16. So we're multiplying by 1/16. Now, if I multiply 1/16 times 49,152, that gets me to the next number, which I add to get to the 5. So I'm multiplying by 1/16 going down, so that's add multiplying. So that's going to be exponential. Which function is below here? This is going up by 2, up by 5, up by another 2, up by another 5. Easy peasy. That's linear. This one, we're multiplying by 2. And how do I get from here to here? 62 divided by 94. Oh, I got some weird decimal, like 0.65. Now, if I multiplied by 2 here, I would have to multiply that times 62 to get 16. And you know what? That just doesn't work. So if I multiply, this was like 0.6595 something, and that doesn't get me there, nor does it get me there. So I'm going to scrap that. So we know it's not linear, it's not power, it's not exponential. If I multiply by 2, did I add anything? So 62 minus 94, that's minus 32, negative 32. So if I multiply the same values, if I subtract 32, that doesn't get me to 16. That would get me down to 30. So logarithmic is out. Well, one more to check. Let's check and see if it's quadratic. So now we look to see if we have constant second differences. This one is 14, 20, this looks like 26, and this one, 94 minus 62, that gives us a 32. Let's see what these differences are here. Here I'm subtracting 6. Ooh, look at that constant second difference. So this would be a quadratic function. What about this one? Here we multiplied by 3, and here we can either say we add 5 or multiply by 2. Now if I multiply this by 3, to get to this next one, I add 5. I don't multiply by 2. So this would be multiply, add. Let's see if it works one more time. 36 times 3 is 108. All right. And add 5 to that. That looks like a good logarithmic function because it's multiply, add. What type of function is this? Well, this one goes up fast and this one doesn't. So I'm going to guess it's either power or exponential. Here I added 2, and here I multiplied by 27. So now if I take 81 times 27, oh, that gets me all the way down here. So how do I get from here to here? It's not by adding 2. It's by multiplying by 3. So multiply will give us a power. If function f has the values f of 5 equals 12 and f of 10 equals 18, let's see if we can find f of 20 if f is a linear function. So I would start by making a table. We have our x values and our y values, and we know we have 5 and 12 and 10 and 18. Well, if this is a linear function, we know it has the property add, add. Here we go up by 5. Here we're going up by 6. So we would have to go up by 5 again and up by 6 here to get to 15 and 24. Now we want to figure out what f of 20 is. So we go up one more 5, which means we go up one more 6 to get all the way up to 30. Now, if a function has the values f of 5 equals 12 and f of 10 equals 18, let's find f of 20 if it's a power function. Well, we can make that chart again. X, Y, and I'll put in 5, 12, 10, 18. Now I'm going to just copy this for future use. Wonderful. So now if we want to find out what f of 20 is now, a power function we learned was multiply, multiply. So I have to multiply by 2 here, and to figure out what I multiply here, what times 12 will give us 18? Well, just do 18 divided by 12, 18 twelfths, or 1.5 is going to be what we're multiplying by. So let's continue the pattern. 10 times 2, again, would get us up to 20. 18 times 1.5 will get us to 27. So now we have f of 20 is equal to 27. Now if this is an exponential function using the same values, this is why I copied it from the previous slide, make it a little easier. Now if I want to find 20, this is an add multiply situation. So here we add 5, we multiply by 1.5 again. If I add 5 over here, I'll multiply by 1.5 again. And remember last time that was 27. But now we've got to get to 20, so add another 5 to get to 20. So now I have to multiply 27 times 1.5, which would be 40.5. So now, if it's exponential, f of 20 equals 40.5. 0.5. Now if we have a logarithmic function, the logarithmic function is multiply, add. So here we multiply by 2, so we'd multiply by 2 again to get to 20. Here we add 6. We have to add 6 more to get up to 24. So if it's logarithmic, f of 20 will be 24. So having that same base will give us a different value for y depending on the type of function that it is. Now, here is where we switch to a different type of function. And so I want you to try to do this one on your own. F of 2 is 35 and f of 6 is 7. Find f of 18 if it's linear, power, exponential, and logarithmic. So pause the video and see if you can do that on your own. All right, here are the answers. F of 18 equals negative 77. If it's linear, if it's power, f of 18 equals 1.4. If it's exponential, f of 18 equals 0.056. And if it's logarithmic, f of 18 is equal to negative 21. All right, hopefully that helps you get through this homework. Good luck.